Greetings, good friends. Gather round. Today we embark on a thought-provoking exploration into the fascinating world of quantum computers and how brilliant minds at Google DeepMind and Google Quantum AI are making them smarter and more reliable. We'll dive into the groundbreaking research paper titled Learning High-Accuracy Error Decoding for Quantum Processors. And trust me, it's going to be an exciting journey. Imagine you have a super-duper, ultra-fast computer that's so advanced it can solve problems way faster than any computer we have today. This is what a quantum computer promises. But there's a catch. Quantum computers are like those tricky puzzles where one wrong move can mess everything up. These puzzles involve tiny bits called qubits, which are the building blocks of quantum computers. Unlike regular bits that are either 0 or 1, qubits can be both at the same time, thanks to something called superposition. Cool, right? But here's the problem. Qubits are very sensitive. They can easily get messed up by their surroundings, which is like trying to keep a snowflake from melting on a warm day. When qubits make mistakes, it's like having typos in a message you're trying to decode. To fix these mistakes, scientists use something called quantum error correction codes. Think of it as writing your message in a secret code, so even if some letters get scrambled, you can still understand the original message. One of the best secret codes they use is called the surface code. Picture a giant grid of qubits, like a checkerboard, where each square is a qubit. This grid helps detect and correct errors by checking nearby qubits to see if something went wrong. But figuring out what the errors are and fixing them is super tricky. It's like having a huge, complicated puzzle where you have to find which pieces are misplaced without knowing the exact picture you're trying to complete. This is where the magic of machine learning comes in. Google DeepMind and Google Quantum AI have developed a special kind of brain, a neural network that can learn to decode these errors with incredible accuracy. They named it AlphaQubit. Think of AlphaQubit as a genius detective that looks at the clues, the noisy syndrome information, and figures out exactly where the mistakes are, even better than any human-designed detective could. AlphaQubit uses something called a recurrent transformer-based neural network. Don't worry if that sounds complicated. It's just a fancy way of saying it's a smart system that can learn from patterns over time. By training on lots of data from Google's powerful Sycamore quantum processor, AlphaQubit became a master at spotting and fixing errors in the surface code. It's like training a dog to sniff out hidden treats. Only in this case, the treats are the correct qubits that keep our quantum computer running smoothly. What makes AlphaQubit even more impressive is that it doesn't just work well on paper or in simulations. It shines when tested with real-world data, handling up to 11 distances in the surface code grid. Imagine being able to solve puzzles not just on a small scale, but on a much larger, more complex board without breaking a sweat. This means quantum computers can become much more reliable and powerful, paving the way for amazing advancements in science, medicine, and technology. But why is all this important? Well, quantum computers have the potential to revolutionize fields like material science, where they can help design new materials with incredible properties, or in medicine, where they could accelerate the discovery of new drugs. They can also transform machine learning itself, making AI even smarter and more efficient. However, To unlock these benefits, we need quantum computers that can run complex calculations without being derailed by errors. That's exactly what AlphaQubit is helping us achieve. There are still challenges ahead. To make quantum computers truly fault-tolerant, meaning they can keep working correctly even when some errors happen, we need to develop even more powerful decoders like AlphaQubit. These decoders must work incredibly fast and handle even larger grids of qubits. But the progress so far is incredibly promising, showing that machine learning can take us far beyond what we thought possible with human-designed algorithms alone. In conclusion, the work by Google DeepMind and Google Quantum AI on AlphaQubit is a shining example of how combining cutting-edge technology with intelligent algorithms can solve some of the most complex problems in science today. By making quantum computers more reliable, they are opening the door to a future where we can tackle challenges that were once thought impossible. So next time you hear about quantum computers, remember the incredible teamwork and innovation that's making them a reality. Until next time, keep wondering, keep exploring, and stay curious.